Reaction mechanisms. You will see them all the time in this class. Very important. So what are reaction mechanisms? So they are a detailed description of how bonds are broken and formed as starting material is converted to the product. And of course, curved arrows are used to show the mechanism of the reaction. There is no such thing as a mechanism without curved arrows. So curved arrows are used to show the mechanism. They explicate. So a reaction can occur in one step or in a series of steps. Basically, imagine this is a reaction. Our question would be, what happened that this went from the reactants or the starting material in the reagent to the product or the products? What happened in between? It's easy for us to know what we started with and what we ended with, but we don't know the story in between. What happened in the intermediate? How did that take place? That's what mechanisms are. So because we cannot watch reactions as they go, like we don't have a camera to see this one attack this one attack that, we have to use data from, of course, coming from thermodynamics and kinetics, as you will see later in this lecture, and devise a mechanism, a series of steps that make sense, of course, supported by evidence. So in this case, you have a one-step reaction called a concerted reaction. Concerted means it happens in one step, where the bonds are made and broken in the same step. So watch. This is a Bronsted-Lowry, by the way, acid-base reaction. So what happens here? Look, the only way we can explicate this is by noticing that the H reacted with the hydroxide here, especially on the O. So what exactly happened here? Well, the only explanation, as we did in the acid-base chapter, is that this lone pair formed a bond with H, but since H cannot form more than one bond, these electrons went on N, went back to N. So here is, use a different color, bond making. Here's bond breaking. All in one step. So we say here that the OH bond, this one right here, this bond, I'm going to put this in red so you can see it. OH bond formed as the NH bond broken at same time. Yeah, so this didn't happen, first, and then it waited for this to receive the electrons, and then this one broke. No, these happened at the same time, simultaneously. While this was forming, this one was breaking. One was forming, the other one was breaking. Now let's look at a stepwise, and these are much more common than these. So you need to ready yourself to see what happens here. So in these reactions, And a stepwise reaction, then this one involves multiple steps. Now, I'm not going to ask you to know the mechanism as of right now, because this is going to come in chapter 10 and later, but you should be able to understand what those arrows mean. So in this case, you have a starting material and you have a reagent. The starting material is first converted to an unstable reactive intermediate, which then goes to form the product. So there's a step in between. Notice here, there is no step in between. Took this, took that, you made the products. No, here you have to go through a step. It's kind of like a middleman. You have to go through a middle person, someone in the middle, and then you go to the next. Kind of like a third party, right? You have to go through multiple steps rather than just go hand deliver something to one person from you to the other person. No, this one has to go through the mail, and the mail has to go through another one, so on and so forth. That's what we mean by a stepwise. Very well. So let's put the electrons on bromine. And of course, you need to start by identifying what is happening here. So what's happening here is that this one is electron rich. Look at this double bond. There's plenty of electrons. And this H right here, this H is electron poor. Because it doesn't have the electronegativity that bromine has. So what happens in this step? Well, what would happen is that this double bond, because it's a pair of electrons, would attack or would form a bond with H. And then, of course, this bond would not stay intact, so then this bond would break. So yes, this is happening at the same time. As this is forming, between C and H is forming, the HBr bond is breaking. So then you have something like this in the middle. And let's say we added the H to this C right there. It doesn't matter for, as of right now, for where you add it, whether you add this H to this C or that C, don't add it in the middle. There's no such thing. But let's say we added it right there. So I'm going to say it's this one so you can see it. This H, let's say. So now watch. This one no longer has the octet, this carbon. Only has 3 bonds, formal charges. This would give us a positive. Aha. So here's your reactive intermediate. And the reason why it's reactive is because it doesn't have an octet as a positive charge here. Now, so here's one step. Notice this is one step. This is step 1. What happens now is you have bromine with this lone pair that went on it, and it has a negative charge. Going back to what happened again. Now, of course, I don't like doing this. I'm just going to point this lone pair to the carbon rather than to the positive charge, because sometimes you might think that there has to, positive charge is simply an empty space. So again, notice how the electrons now went from the bromine to the carbon. This lone pair formed a bond. Therefore, now your final product would look like this. Very well. So let's look at what happened in the first step. In the first step you had, so this is step 1. And of course, this is step 2. In step 1, what happened was that you had a Bronsted-Lowry we're just going to call them Bronsted acid-base reaction, RXN. In step 2, you had actually a Lewis acids and bases. Or a nucleophile-electrophile reaction. So just one last thing. To explicate this for you so you can see it. The H, this was again electron rich, or you could say this was a base. This was the acid. In the second step, you had the electrophile and you had the nucleophile. This was the Lewis acid. We're going to call this La, and we're going to call this Lb. That's the bromine. Very well. So no need to, I'm not asking you to draw this from scratch. What I'm asking is you should know what those arrows again mean, what they mean.